Hey, students, I'm going to go over how to make a graph here, going over our test. So here's the answers you should have gotten for time and distance. I'm going to circle, we're going to graph distance and time, okay? So you should have graphed, that's what the question was asking for. Okay, so distance and time. Why can't I scroll? Ooh, I can't scroll because I selected that. I got to go back here. Oh, I just learned how to, bet you I can zoom now too. Oh man, I should have. Look at that, I'm learning things. Okay, yes, I got a bunch of tools right here. Okay, so we want to graph distance here. Let's get this set up so you can see all this all at once. Okay, Leia, let's. Can I move my face? I cannot. Oh, I can flip myself. Okay, sorry, Mr. Worst getting distracted. Okay, so we're gonna graph distance and time. Okay, where do we start? Okay, you could start by putting a title up on the top of your graph. I think that would be good. Okay, so you'd say like distance and time for a blah, 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 whatever the object is. I believe this was a rolling ball, distance and time for a rolling ball. Okay. You could even call it distance and time for an experiment, for the experimental objects. Yeah, I don't want to set case law on like what would be the right or wrong answer for the title. But basically, you have your independent variable down here on the bottom, dependent variable over on the side, and then the object that you change the independent variable for and measure the response of the dependent variable for. So distance and time for a rolling ball. I forget, and I don't want to scroll up. Okay, distance and time for a ball. How about that? All right, we have a title. We have independent with its units on the bottom. This is what we're going to change intentionally in the experiment. The responding variable, dependent variable, that's over on the y-axis with its units as well in meters. Okay, so to scale it, what you do is you got 10 boxes down here to scale. We always start at 0, at least in this class. Start at 0, and then we're going to count over by the same number each time, okay? Kind of like counting by 5s, counting by 2s, counting by 10s. What are we going to count by? That's the scale. It's basically what we're going to measure our data in. So we want to have accurate measuring things in the graph. Okay, Mr. Words, don't get too distracted. The way you do that is we have the number of lines to fill. So I got 10 of these little boxes down here to fill in. And I take the highest number divided by 10. Okay, so highest number for time is 2. So 2 divided by 10 would be 0.2. So I could count by 0.2s because we can, 0.2s are easy to count by. So 0.2, why is that popping up? Oh, it's because it's like autofill. 0.4. So I'm counting by 2s each time. It's like, it's a scale going across. It just like a measuring tape measures by the same number for each, like the same block of distance should be the same amount over. So I'm counting by 0.2, 0.8. I don't like how that pops up. Okay, 1.0, and my face is there, so I'm going to stop. I'm not going to finish the whole thing here. Okay, so 1.2, 1.4, et cetera, et cetera. I just scaled for time. And I will eventually get over here to 2. In fact, let's get rid of me. Okay, yeah, so 1.6, 1.8, 2.0. Okay, so we were able to get our data within the graph. That's the important part. That's why you divide the highest data value by 10 for that type of data value. So our highest time was 2. We divide it by 10 because we had 10 boxes to fill in for our scale. So 2 divided by 10 is 0.2. Let's do the same thing over here for distance. Okay, highest number is 16. We have 10 boxes. 10 divided by 16 is 1.6. That's really hard to count by. So I'm going to round up to 2s. We're going to count by 2s now. So 2, 4, 6. Oh, Mr. Worst. Oh, what's going on here? Oh, it doesn't like that box. Why doesn't it like that box? Okay. Pay no attention to 6, 8, 10. Oh, man. 12.